Welcome to springlib.
To solve this problem, we need to approach it step by step. So first, we want to find the system reliability. Given stress X is normally distributed with mean of 11,000 and standard deviation of 2,400, and the strength of Y is normally distributed with a mean of 15,000 and standard deviation of 1,500, and the reliability is the probability that the strength of Y is greater than the stress X. So mathematically, that's R is equal to the probability that Y is greater than X. To find this probability, we consider the distribution of the difference, and we'll use Z. The random variable Z will also follow a normal distribution, where the mean of Z is going to be the difference between the mean of Y and X, which is 4,000, and the standard deviation of Z would be the square root of 1,500 squared plus 2,400 squared. And now we want to calculate the standard deviation of Z, which is about 2830.19. And now, if R is equal to the probability that Z is greater than 0, that's the probability that Z minus the mean of Z over the standard deviation of Z is greater than 0 minus the mean of Z over the standard deviation of Z, which is the probability that Z minus 4,000 over 2830.19 is greater than 0 minus 4,000 over 2830.19. And so R would be equal to P times the new Z is greater than negative 4,000 over 2830.19. Z prime is the standard normal variable. And 4,000 over 2830.19 is about 1.41. If I go to three places, it's 1.413. And so R is equal to the probability that Z prime is greater than negative 1.413, which would be 1 minus the probability of Z prime being less than or equal to negative 1.413. Using the standard normal distribution table, this corresponds to 0.0792. So R equals 1 minus 0.0792, which is 0.9208. So the system reliability for this failure mode is about 0.9208. Achieving a reliability goal of 0.99990, we need to find the new mean strength Y prime Y, such that the probability that Y prime is greater than X, which is 0.99990. We can use the inverse of the standard normal distribution to find the required Z-score for this. The corresponding Z value for the probability that Z prime is less than or equal to Z is going to be 0.00010, and that's about negative 3.719. Mu prime Z is equal to mu prime Y minus mu X, and solving for mu prime Z, negative 3.719 would be equal to 0 minus mu prime Y minus 11,000 over 2830.19. And solving for mu prime Y here, that'd be 11,000 plus 10,518.43 about. And it comes out to 21,518.43.